Hey, I think we have kind of a fun problem here today from the MIT Integration Bee 2022. This was regular season problem number 20. We have the integral from 0 to infinity, 36x to the 5th minus 12x to the 6th plus x to the 7th, all times e to the minus x dx. Okay, my first thought here was like integration by parts, and I was thinking that's going to be a little tedious because you have x to the 7th power and you're going to be integrating over and over again. But then I realized if we just break this up into 3 integrals and distribute in the e to the minus x, this is actually going to be in the perfect form to use the gamma function. Okay, so we have your formula for the gamma function, and it tells us we have an integral in this form from 0 to infinity, check. Then we're going to want an x term with some exponent, which we'll call n minus 1 times e to the minus x dx. Then just notice, like I said earlier, if I break this into 3 integrals, it's going to be in exactly this form. So let's just start with the first one, our 36x to the 5th. So what I'm going to do is we'll write this. I'll bring my 36 out front. We're going from 0 to infinity, we're going to have just x to the 5th, e to the minus x dx. Now for this n minus 1 form, if I write my exponent here, if I write this 5 just as 6 minus 1, then our n value is going to be 6. So for this first integral, we'll just take whatever 36 up front, multiply by it. But then for the integral part, this will be gamma of n, but in this case n is 6, so we're looking for gamma of 6. We'll come back and calculate this in a minute, but let's just go on to the next integral for now. Okay, next we'll deal with this middle piece, and I'll take my minus 12 up front, and again we're going from 0 to infinity. We're going to have just x to the 6th, e to the minus x dx. And again, writing this exponent as, again, we'll write this as 7 minus 1 so that our n is 7, and this is going to give us minus 12 gamma of 7. For this last one, we've got nothing to factor out in front, it's just going to be a 1. So then we're integrating from 0 to infinity, x to the 7th, e to the minus x, and writing this as 8 minus 1. This integral is just going to be 1 times gamma of 8. And now before we calculate all of our gamma values, I just want to point out I've added this piece right here. So once we've got our integral into this form of the gamma function, it's pretty easy to calculate because we can just turn this into factorials, especially when it's integers. We know how to do factorials, so we have an easy way to calculate. So let's see how this is going to work. So for our first one, we're going to have our 36 up front. So for gamma of 6, we'll use n minus 1, so that's going to be 5 factorial. So we're just saying this is going to be 36 times 5 factorial. Then for this next one, we'll have our minus 12 out. Again, gamma of 7, n minus 1 is going to be 6 factorial. And then for this one here, this is going to be just 7 factorial. And so again, we just need to add all this stuff up, right? Because originally this was all in one integral being added up, so we're just going to need to sum this. And I'm just going to make my calculation a little easier. I'm just going to manipulate this a little bit just so it's easy to calculate. So I'm going to write, so for 36 is 6 times 6. If I take one of the 6's and put it in front of a 5 factorial, I can write this as 6 factorial. And then here we have minus 12 times 6 factorial. And 7 factorial, I can write that as 7 times 6 factorial. So adding 7 and 6, we get 13 minus 12 is 1. So we're just going to have, for our solution, 6 factorial. If you multiply out 6 factorial, you're going to get a final solution of just 720. Thought it was just interesting how easily this simplifies once you have this one little formula for the gamma function, and it cleans up pretty quick. So we'll stop it there. Thanks everyone for watching. Have a great day.